Alright, we talked about arithmetic sequences. Now we're going to look at our other type of sequence that you're responsible for knowing, called a geometric sequence. So here's an example of a geometric sequence. We can see that it's not arithmetic because it's certainly not going up by a fixed amount each time or going down by a fixed amount. Alright, so there's no common difference. Instead, we have what's called a common ratio. And we're going to use a lowercase r to represent our common ratio. And well, first of all, if you were to try to establish the pattern here, hopefully you can see that we would have to multiply by 4 to get the next term. So the idea of it being a common ratio, it's very similar to what we saw before. Working backwards, all right, now ratio implies a quotient, or a fraction in other words. So the ratio part here, there's a common ratio. All right, if we were to work backwards and do the second term divided by the first term, that's going to be the third term divided by the second term. All right, you can see here that we have a common ratio of 4. Okay, so the r value is 4 in this geometric sequence. Now, we have a general formula, just like we had a general formula with arithmetic. Okay, and this is the second of 5 formulas that are given to you in your formula packet. Okay, so this is the formula. We have u sub n is equal to u sub 1 times, all right, r raised to the n minus 1. Okay, this is the general formula, just like there was a u sub n general formula for arithmetic, but this time it's for geometric. Okay, notice how there is an r in there, not a d. Okay, so let's look at an example where this is used. Okay, here we go. So we're looking to find the 12th term in this sequence. Now notice how the first term is 7. All right, so that means our u sub 1 is 7. And note how the signs are alternating. We go from positive to negative to positive to negative. So that means that our common ratio r is going to be a negative. So to find it, now here hopefully it's obvious to you that the common ratio is going to be negative 2. If it's not, or if you have a question that says show that the common ratio is negative 2, understand that comes from working backwards here and turning these terms into a fraction just like we showed before. So if we were to divide working backwards like that, we can show that the common ratio is negative 2. So keep in mind, IB loves these show questions. Okay, so show something is whatever. Okay, so they might say show the common ratio is negative 2, and this is how you would do it. All right, so to find the 12th term, we're going to use our formula over here. Okay, our general formula for finding any term. So u sub 12 is what we're after. The first term is 7. The r value is a negative 2. And then we have a 12 minus 1 for our power. Okay, so this becomes 7 times negative 2 to the 11th. Now, write yourself a note, all right, and star it, that this is not equal to negative 14 to the 11. Okay, you cannot multiply those two together. Or you'd have to do your PEMDAS, you'd have to do your negative 2 to the 11th power first, and then multiply it by 7. You're going to be allowed to use a calculator with these questions when the numbers get really big. So negative 14,336. Oh, here comes my kids. Hello. And that's it for this piece. Okay, goodbye. Okay, next example. We are told that u sub 7 is 256 and u sub 4 is 32. We're looking to find the first term and the common ratio r. So 1, 2, 3, 4, 5, 6, 7. So the 7th term here is 256 and the 4th term is 32. Okay, trying to find this first term and the common ratio. So we saw something similar with our arithmetic sequence, but this is a little bit more complicated. So we're going to go back to our formula here. This is our general formula for a geometric sequence. Oh, and by the way, suppose that we are told too that this is a geometric sequence. All right, so we're given these two things and we're told that this is a geometric sequence. So we want to know that additional piece of information. Okay, so that means we have this general formula that is applicable. So we know that if we put in 256 for u sub n, we don't know u sub 1, we don't know r, but if 256 goes in for u sub n, that means that we have 7 for the n value. So that means 256 equals u sub 1 times r to the 6th, right? And likewise, if we plug in our other known fact, 32 is equal to u sub 1 times r to the, it would be 4 minus 1, which is 3, so 32 is equal to u sub 1 times r cubed. All right, so these are two equations here with two unknowns. So what we're going to do is we're going to solve a system of equations. So we're looking to solve our system of equations for our two unknowns, u sub 1 and r. So I suggest you use substitution. So if we were to take this equation here and solve for u sub 1, u sub 1 would be 32 divided by r cubed, right? So that's what u sub 1 is. So what we could then do is we can take this expression and put it into the other equation where we see a u sub 1. So if we do that, we're going to have 256 equals u sub 1 is the same as 32 over r cubed times r to the 6th. Notice that by doing this, we have just a single equation with a single variable. So we can now solve for r. So this would become r cubed, okay, when you simplify your r's. And then if you divide over your 32, you're going to end up getting 8 equals r cubed. And so that means that r would be 2. So there is our common ratio. Okay. Now we need to find our first term. So we're going to plug into either one of these equations that we started with, either that one or this one. Okay. So how about we go with the 32 equals u sub 1 times r to the 3rd. Okay. Or you could have plugged into this one, 32 over r cubed, right? So either way, when we do this, plugging in a 2, 4, and r, we get 32 over 8. So that means that my first term is 4. Okay, so if I were to back this up here, first term is 4. Okay, so it's the idea that we have a common ratio, so you would have to multiply by 2, right? So if you were to kind of check this, if the r value is 2, all right, if you double 4, you get 8, double 8, you get 16, double 16, you get 32, and so on. Okay, so that is an example where you're given a couple terms and asked to find u sub 1 and r. One more example. All right, so in this example, we're given 5, 15, 45, dot, dot, dot. Notice that we're not told that this is a geometric sequence. You would just have to look at it and be able to recognize that the r value is 3, since you are in need of multiplying by 3 to get the next term. We're looking to find the least value of n such that the nth term is greater than 50,000. So to do this, we're going to once again use our general formula. Okay, and we know that r is 3 and our first term is 5. Okay, so we can plug in these pieces. So u sub n is equal to 5 times 3 to the n minus 1. And of course, I know there's no one out there who's tempted to turn that into a 15 raised to the n minus 1, right? We know better. So that is our general formula here for finding any term. We want the first one, the first term, that's going to be greater than 50,000. So we're really talking about an inequality here. So you're expected to write this inequality. All right, what we're trying to solve is we're trying to figure out when this 5 times 3 raised to the n minus 1, which again enables us to find any term, we want to know when is that going to be greater than 50,000. Okay, so a couple different ways of solving this. First, if you were to solve it algebraically, divide by 5 first. We're left with 3 raised to the n minus 1 is greater than 10,000. And then from there we can log each side. So we would have that n minus 1 drop down. Okay, so we're logging each side. And then we would divide over our log of 3. Okay, so from there we would end up with 8.38, and then if we were to add over our 1, we get n is greater than 9.38. So let's go back and understand what this question is asking for. We want the least value of n such that the nth term is greater than 50,000. So the question becomes, well, how do you round? Okay, now remember, n represents the term number. So is it the 9th term or is it the 10th term? Well, even though this 0.38 would lead you to believe that we would have to round down to 9, if we were to look at the 9th term, it would not exceed 50,000. Okay? We would need to go to the 10th term for it to be greater than 50,000. So n would have to equal 10. Okay? Now, that's one way of approaching this. The other way of approaching this, and this is a way that I would encourage you to do using your calculator, is to use the table. Okay, so in y equals, you would enter 5 times 3 to the x minus 1. Okay, so we're going to use x as our n. Okay, and I really want you guys to make sure you're doing this and not just writing it down. Okay, but if you were to look in your table, okay, when x is 8, you would see 10,935. When x is 9, you'd have 32,805. Okay, so notice how when x is 9, or the 9th term, we have not yet exceeded 50,000. However, if you go to the 10th term, you're looking at 98,415. Okay, so that confirms this right here. So you do not have to use logs. Okay, you can simply use your table. Your work would be exactly what I am boxing in here. Okay, so please make note that you used the table on your calculator. Okay, so that's it for now. Goodbye.